Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. And you know, we have a bit of a treat today, I don't mind telling you. Yesterday, Alan updated 4Coder with a ton of really good stuff. And so it's pretty awesome. I actually switched to it at work, and I programmed all day today with it, and it's like totally great. So I'm pretty excited about this new build. It's like way better than the previous build and has all sorts of things in it that that I needed. So I copied it during the pre-stream. I copied the new 4Coder into our directory. So today's programming will be taking place courtesy of, and I don't ever remember the version number, so I'm just going to look. Will be taking place courtesy of 4Coder version. I don't know. How do you tell the version? I love Patreon dearly. I think they're a great service, but I never know how to use the site. I never know. I have no idea. It's always like they change the layout, and I get totally lost. Maybe if I just go to the regular 4Coder site, it'll tell me the version. I don't even know. Maybe if I just launch 4Coder, that'll tell me the version. I have no idea. It's a good question. Let's try that. Let's try that. Oh yeah. So there we go. That's the easy way. So this programming today is brought to you by 4Coder Alpha 4.0.2 Super. And I'm assuming that the 4 is because it's 4Coder, which is hilarious, by the way. That's so funny. Since it's an alpha, you know there has not been a major release yet. So that's pretty great. Anyway, that is pretty great news because, yeah, like I said, there's a lot of changes in there that I was looking forward to. So anyway, that's what's going on today. Today is day 256, so we now need exactly 9 bits to store the day number of Handmade Hero, which is certainly momentous and good. If you are trying to follow along at home, you want to use the day 255 source code. I am today just going to get our profile view working because we did the structural work yesterday, and now I think probably mostly we just have to do debugging and then some beautification, and it should be somewhat usable already. We made a lot of progress yesterday on it. So I'm going to go ahead and get started on that. And I'll show you where we ended up. Let me go ahead and load Handmade Hero here. Code base, oops, not core, handmade.prj. And let's build. Okay. So here we are in Handmade Hero at the current state of affairs. You can see in here the profile view. We can drag out the block, but this is just complete nonsense here. And so something about the way that we are recording our values is obviously busted. And what's interesting about it, it's kind of a neat bug. You can see that it's sort of periodic in nature. So the way that we're recording the way that we're collating this information per frame is somehow busted in a way that our use of the absolute clocks must be broken such that we're like, you know, when we do our 64-bit subtracts and move them down to U32s or whatever, we're doing something stupid. So we end up with a value that actually, you know, it matters where you are in absolute time, what the bar graph looks like. So I imagine this will be a kind of fun bug when we actually go see what it is. I'm going to go ahead and see if I can figure it out right now, in fact. So the first thing I'd like to do, actually, before we go any further, is I just want to review the code that we wrote, because we haven't had a chance to really look at it. We sort of just wrote it all yesterday and then ran it once. That's all we did. And so I'd like to go ahead and sort of analyze that a little bit. And let's go ahead and search down to where we were recording this information. So we had this concept of this profile node that we were building, and this is the code actually here that draws it. I'm not going to look at that code quite yet. I want to look first at just the code that records it and see what I think about the recording process as we go. So the time when something gets recorded as a profile block is when it encounters the opening statement. So for example, inside Handmade Hero, right, if we were in timed block, for example, you can see right here this timed function call, that opens a timed block so that right when we get to this line, basically, is when we're going to record one of these begin blocks. So later when we're collating, that's what we're seeing there. And then when this goes out of scope, it's a little utility that's got a constructor destructor such that when it goes out of scope, down here, we will get the end block. And that's the paired version that comes out right here. So when we see this begin block, what we do when we come through here is we will look to see whether or not we have basically a parent scope. So was there something that was already open as a profile block on this thread, right? And it's very important that we do it per thread because we may have many threads executing at once. And if we do any kind of profiling in those different threads, we can't just look at a single global variable or a single piece of state that says what's the open block, because each thread has its own open profile block potentially, possibly many of them as it goes down. So we kind of have to respect that. So that's why during collation we look to see what thread are we talking about right now, and does that have a block that's already open. So if it does have a block that's already open, we pick as the parent event whatever the profiling node was that we made for that block. And we take as its clock basis, meaning the beginning thing that everything else will be relative to, we take as that clock basis whatever its opening events clock was, because it's a requirement, obviously, that any clock that happens out, when I open a block, the RDTSC counter that we're using for profiling has to continuously go up. So once we pass a particular block, any block that opens after that block had better have a later clock value. If it doesn't, something's going horribly wrong. And in fact, we could assert that, maybe we should in here, just to make sure that we're not doing something weird and we haven't messed up our recording. Because if we ever saw a clock value that went backwards, that would be really bad and weird, right? And RDTSC is going up probably by something like 4 billion a second, which means that it would take 4 billion seconds to wrap. So that means we'd have to leave a machine running for a really long time to ever see a wrap. So we're probably not going to ever deal with that in any meaningful way that we care about. And so we just should not see clocks go backwards. No standard run should ever see a clock go backwards. So assuming that we did that correctly, that would be our clock basis here. On the other hand, if it turns out that there is no parent event, that means that there wasn't a root profiling node, and that's just the profiling node for the whole frame, the one that everything kind of goes inside of, right? And what that means for us is that we need to create the root profiling event for this frame so that we can store things at that top level, right? So what we do there is we store a synthetic event that we just don't have any information in it, and then we initialize that profile node to basically be nothing other than a duration, which is however long the frame okay, well, there's the bug right there. You guys see the bug? You see it? Does anybody see the bug besides me? I don't know. There's too much lag, and so I can't even really look at the chat because, there's tons of lag on there. So I already see the bug, or one of the bugs anyway. The bug is pretty simple. The bug is that we are using the end clock value before it's ever been written, right? Because the collation frame is the frame that we're currently using. And so obviously, there would be no way for us to ever actually do anything, right? There'd be no way for us to ever actually compute a duration because no one's ever written the end clock value in here. So that's just a bug that we're going to have to fix. And it seems to me like probably what we need to do is just set this duration at some other time. So assume that this duration is 0 for now. And there might be another bug in here too, which we'll talk about in a second here. But essentially what we need to do is when the collation frame is finalized and it's actually added as a frame, that's probably the time when we need to do it. So here we are at a frame marker boundary and we're recording the end clock. That is a time when we could do this. That is the time where we could say, if this collation frame, has a root node, or a root profile node, then at that point we can actually do this particular operation, right? Let me go ahead and put that in here. So yeah, root profile node, that's going to be whatever the duration was here. That's going to equal this sort of change. And yeah, that's all there is to that. Let's see. Left of profile node must have class struct union debug stored event star. Use arrow instead. I agree with that. There we go. So that is the appropriate fix for that, because we were trying to compute the duration before we ever could. Now there's one other thing, which is that the clock basis we never set. And so that's a bug as well. The clock basis here we have to set, so it's set to the open event in this case, but in the case where we don't have an open event, we would want to set it to the initial clock for the frame, which we do know, right? So those two were wrong. Like, we just didn't do it right. There's nothing else to say about that. It was not a subtle bug. It was just an obvious bug, which is fine. And hey, now that we've done that, we're getting what looks to be like a much more plausible profile result here. And in fact, if we go ahead and re-enable our ability to sort of step through here, we can actually also pause, I suppose. Although, you know what? I don't know if our profile data, I don't know if we have the ability to pause our profile data. So we're probably going to need to do that at some point, so we can sort of stop collecting profile data, if that makes sense. So in here, we have the ability to do that. I just don't think we have any control over it at the moment. What we want to do here is be able to hover over this thing and be able to see what these blocks actually are. And we sort of had that functionality already, but I if zeroed it out because we don't actually know at the moment anyway how to print out stuff like that. So I'm just going to go grab that code that we had before and try to turn it back on. Like this is it, right? This is it right here. So I'm going to turn this back on. And you can see that our current problem is just that we don't have this information the way that it was before. Now, what I can do, however, is since we know some information about this region, we know the cycle count and all the rest of the information, like the GUID information and all that stuff. We actually know all that. So I think probably all we'd have to do to have a semi-usable printout, and we probably don't. We probably want to do something a little fancier in the future, but just as a beginning, we can just say, here's the here's the GUID that it came from, and then we've got, obviously, the profile node has the duration, and that's all we would need to print out for the cycles. So that's really all that is, right? So now I think if we go in here and open this back up again, I should be able to ask what one of these things is. So that's the frame display time, and back here in the corner, this little tiny one is the executable refresh time. Whatever that guy is, that's debug collation in there, I guess. Yeah. So the other thing that I'm gonna have to do is I'm going to have to make it so that we can see, like, we don't have a way of consistently coloring these things such that we would know that they wouldn't all amount to the same colors. And in fact, the thing that I'm doing right now is really stupid because I'm using a pointer and then I'm modding by the array count. But you know that pointers are never going to have any information in their bottom bits, so that's just, arbitrarily stupid. For people who don't, this might not be something you would ordinarily think of if you're new to low-level programming, so I'll just point out what I'm saying because it's probably slightly interesting at least. So, what did I do here? What did I sort of scoot in here? Well, I just wanted some way to randomly pick a color that might be different for each one of these things. Now, obviously, we're going to have a lot more things in here than we can assign unique colors to anyway. So we're going to want to draw a border around the box that allows us to sort of see where the regions are. So that's like a separate thing that we're going to have to do one way or the other. But it would still be nice to sort of randomize the colors. So what I did is I said, well, whatever the pointer to the GUID is, we know that no two people can point to the same GUID. Because if they both point to the same GUID, that means they both have the same GUID string. And that means that's not a very good GUID string now, is it? So we obviously know that that's not the case. But what I did is I just took the value that the pointer is, the actual numerical value of the pointer, right, whatever byte it was pointing to, and I modded it by the array count, which is how many colors we had, and I just said, well, whatever that is, so it's just basically like wrapping through this, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, whatever, and then back to the beginning and keep through again, right? So the problem with that is that if you take a look at what the distribution of these values actually is, you're not going to get any information in the low bits because a pointer is usually going to be aligned to a 4-byte boundary, right? Because as you know, we typically, for whatever alignment reasons in the past, we typically have pointers that are aligned not to a byte, right? They typically don't go up by 1, 2, 3, 4, 5. They're typically aligned to a D word, which is a 4-byte boundary, or perhaps even to a like one of the SSE size things, depending on how the allocator is going. In our case, they're mostly going to be 4 bytes because our allocator, we defaulted to 4-byte alignment, so that would be D word aligned, right? And so, 0, 1, 2, 3, 4, 5, 6, 7, whatever, you never see 1, 2, or 3. You only see 0 and 4, you never see 5, 6. We only, these are the only values we actually see coming in through these pointers. So the color array count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It happens to be a perfect multiple of 4, right? So what that means is we're only going to ever use 3 colors out of this thing. Because we're never going to have a pointer that's not on a 4-byte boundary, and we're never going to, and this isn't the, this isn't a prime, this is why you might want a prime number of colors in here, right? So what I'm going to do, because I'm super cheesy and weird, is I'm going to go ahead and say, let's make this a non-multiple of 4 so that it will have more of a beat frequency to it. In fact, if we could make it prime, that would be great. Right now it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so really there's 12 entries in it. If we wanted to, 11 would be prime. So I could just make it so that we don't use this last value, right? And hey, look, all of a sudden now we can actually see the different zones because we're actually taking a look at, we're actually using more than 3 values of the colors, right? So now we're getting a much more stable view of our profile, and this is already super informative, right? Just looking at this, you can kind of see how our frame time breaks down. You'll notice that this giant sort of fluorescent bar here is our frame display time. And that is us waiting for the vertical refresh, right? So what's happening right now in our code is we are doing a bunch of work. This is the work in here, right? And I guess we learned even more actually from this, right? Here is our input processing code, right? If that makes sense, right through there. I don't know why that's so long. It's kind of interesting that is long. I wonder if that's actually correct. Oh, you know what? That might be correct. Hold that thought. Anyway, let's move on. Hold that thought because that's an interesting thought. So this is our input processing. Here is the actual game code, all fitting right in there, right? Here is the debug collation, which I said is very expensive because we're churning through a lot of stuff in there typically. So like let's actually look in the more this will look even worse, right? This is the worst case for it. Oh, but it's not on top. Before I go any further on that, let's actually go ahead and use our z-biasing here because we need our profile data to be on top. Remember we had to do the thing where they sort the rectangles. We sorted like our sprites so that they would be on top for the debug code. We need to do that same thing for our display here. Otherwise, we're never going to see it. So I don't know if you remember this, but basically like our renderer sorts everything from front to back. If we don't make sure that the debug stuff is sorted all the way to the front, then we have this problem, right? So let's go ahead and switch over to Handmade render group. And inside Handmade render group, we have that z-bias concept there. Oops. Somewhere. Don't we? Do we? Sort bias. That's what I meant. So we have that sort bias concept. And what I think I'd like to do is I'd like the sort bias, I think, to be part of the transform, right? Because we've got this concept of an object transform. And the object transform gets passed through, and I think that's a more appropriate place to do it, so that you don't have to pass with every call. You can just, whatever that object transform was, it's in there. So like right here, for example, I'm going to go ahead and say that inside this object transform, I don't know why we have, it would be nice if I had said why we want to move this out to its own thing. Ladies and gentlemen, when you're ready to do, maybe you should actually give yourself enough information to actually do it later. No worries. Anyway, in here, I'm going to go ahead and say that there's a sort bias. And that way, inside the object transform, we can pass in, when we set that up, what we want that sort bias to be. And then instead of dealing with it here, the sort key, when it's computed, will automatically take that into account. And that way we can sort of get rid of this weird like pass-through behavior that's happening there. And so when we do that get render entity basis p, you can see us computing the sort key down at the bottom. What we can do is we can adjust that sort key right here. So you can see the way we're doing it, we're basically taking the z and sort of sorting things based on some sort of like hackiness that made it so that upright things sorted one way and flat things sorted the other way, because we're in 2.5D, right? And we subtract y. So what we can do with our sort bias here is we can just say like, okay, we're just going to start off with the sort bias. So whatever the object transform sort bias is, that's going to be our initial bit, and then the sort key gets computed based on the rest of it. So yeah, so there you go. Hopefully that makes sense. So then down here, where we've got this sort of weird nonsense that we're doing, right, where we have this sort bias stuff happening, we want to go ahead and make this part of the make this part of the transform. And I don't know whether I want to do a front and a back plane transform, but I easily could. So up here, for example, I can just say you've got like there's this default flat transform, right? I'm going to call this maybe I'm going to call this like main transform and shadow transform, and I may make these. I may want these to actually just be things that are in the debug system for real. Like I may want them to just be stored in debug state. In fact, I probably do. But for now, I'm just going to say, okay, the text transform, sort bias, or soft bias, not what I wanted. I'm just going to make these two arbitrarily huge numbers so they always sort to the front. And that way we've got the shadow transform and the text transform. And we can put all of those things on separate planes by just picking which transform we use, right? So as you can see, that won't fix the problem because we haven't put it in the other routine yet. So when we switch into here, we're still wrong. But so now what I'm going to do is I'm just going to make these first-class citizens of the debug system itself, so I can, oops, that's not what I wanted, so I can always use them in all the debug routines without having to set them up, and they'll just be there. So here in the debug state, I'm just going to put them right, in here, so they're always usable. And I don't know, we might actually want, I don't know if we want another one, which is like, there's the text transform, there's shadow transform, and there's probably like, you know, in order, there's probably something like a backing transform, which is like we probably want several transforms, and we just pick which layer. So they're basically layers that we can use, right? So yeah. So now I'll just go and add that to, add that to wherever I have a bunch of work I got to do on my 4-coder config. As you know, I switched to modal editing, and I kind of like Emacs was super buggy, so I never really tuned all my keys and stuff to be very good in my modal Emacs, and I just ported that straight over to 4-coder. Now that 4-coder is like what I'm editing in everywhere, I need to spend some quality time. Maybe if I'm lucky this weekend, I'll have some time to do it. Like tuning how all my keys work, because I spend too much time now trying to do edits, and now that I can program 4-coder in C, Emacs, of course, I always had to program an Emacs list. Now that I can program 4-coder in C, I'm going to be able to make really great key bindings, I think. And so I'm kind of looking forward to being able to do that. And I hope I can do that soon, because I'm not even close to as fast as I used to be when I didn't have the modal key bindings. Which is just, that's, what happens when you've been programming your whole life non-modal and then you switch to modal. It's hard to make yourself be the same speed, right? Okay, but that's neither here nor there. Let's go ahead and get these initializations going here. There we go, debug state. I think that should do it. I guess I'll put this backing transform in here as well. Oops, Bakyong. Sounds vaguely Vietnamese. There we go. Backing transform, sort bias is going to be like not as much. I don't really know what my algorithm is here for how these things are being assigned. They just have to be numbers that are larger than any other value that the game might use, but that's it. Yeah, that's all for that. And now I need to go actually use this transform up in the profile code, right? So in draw profile in, now what I need to do is make it so that my push recs can use this. Thankfully, I already take a transform with the push recs, so that's kind of nice. And what that means is I can just go ahead and pass the debug state backing transform here, and then all the rectangles that get drawn will go through that. And that's nice. But we should probably also take a look at anything else. Like here's another one. I don't even know what this is doing here, but let's go ahead and put this in here, backing transform. And undeclared identifier, that's because it's debug state. And I think the look grabby bits, like all that stuff is also gonna have to be kind of rendered properly. So you can see here, like all this stuff, right? Like all that stuff needs to be in there too. So when we do end element, that stuff's got to be in there. So what is these are, yeah, this is just like corners and stuff. So I'm gonna go ahead and make this be, just transform. In fact, I guess I can just do this to be cheesy. There we go. So let's take a look at this and see if that helped at all. So here we are viewing the profile as before. I'm now going to hit the spacebar, and there we go. So now we've still got our profile view, and that's pretty great, right? So let's take a look at our timings now. You can see that this is the amount of time we're spending in the game update. This is the amount of time we're spending in input processing. This is the amount of time that we can't even hover over, that's like executable refresh and other junk like that. This is the amount of time we're spending in debug collation, which again is substantially more in the game because there's a lot more things to do in there. And here is that frame display, which is us just waiting for the vertical refresh and the graphics card. Like who knows? We don't know how much of that time is the graphics card actually doing work, and how much of the time is it just waiting for the v-blank, because obviously we don't have insight into that. And to be clear, it's overlapped as well. So really, what's happening with that code is a little bit slightly different, right? If you really want to talk about what's happening there, it's probably something more like, we take that profile there, right? And we sort of got like, oh, well, there's this, and then there's this, and this, and this part here is the frame display. And so you can imagine this sort of stacked frame by frame, like here's frame 0, that is going to repeat itself, right? And you can see that it's jittery, which is very common on, modern machines are very, there's a lot of, they're not like the machines in the old days where everything took exact fixed amount of time. Thanks to caching and varying power and different, threads interrupting, the operating system preempting you, all this stuff, you're never getting very stable frame timings anymore. So you do expect the jitter and you get it. But roughly, we're going to have the same thing repeat, right? So this time here, we're not doing any work because we've already finished all the work we had to do, and now we're just waiting. And we could go start on the other frame, but we really don't want to get too many frames ahead, right? And we already know that we can do a whole frame in less than the amount of time it takes for the graphics card for the 60 frame a second update anyway. So we're really just waiting here. But what I wanted to emphasize is right here, right where we call swap buffers. It's sort of wrong to think about what happens there as the graphics card then draws the frame and then waits for the V blank, right? That would be what would be tempting to think about, but that's not what actually is happening. What actually is happening probably is if you imagine that this is frame 0, right? Then actually on frame, or rather, let's not pretend that. Let's pretend frame 0 is back here. Let's pretend this is frame, like 5, and this is frame 6. What's actually happening is this waiting for the V blank is actually something that's happening from frame 4. So you're actually waiting for frame 4 to display, right? Potentially. You may actually be waiting for frame 4 to display, and what you're actually kicking off here is frame 5 to be displayed here, right? And so the graphics card may be 1 frame ahead of you if it wants to be. And technically it could be 2 frames ahead of you if it wanted to be. So you don't, unless you've gone and profiled it and determined that that is literally what's happening, don't assume that what's going on is you call swap buffers, it draws the frame in here, and then it waits for the V blank here. What may happen is you call swap buffers here, it draws the frame here, right? Displays the previous frame here in the middle of having drawn this frame, and then waits for you to submit the next one after that, and then will display this guy here. So it's really staggered a lot of the time, and it's important to kind of understand that that's what's happening, only because if you want to kind of understand problems you may have or performance things you may see down the line, it's important to understand that the graphics card and the CPU are not necessarily operating in lockstep. They're 2 different processors that can be going asynchronously, and they may decide to stagger their operations. Specifically so each of them has, like if you look at how this works, each of you now has 1/60th of a second to do your work. By adding a frame of latency there, you can do 1/60th of a second worth of work on both the CPU and the GPU without reducing the frame rate. Now you do add a frame of latency, right? So it's not as good as if everyone was in lockstep, but it's still pretty good. It's better than reducing the frame rate to 30 frames a second, right? You'd much rather have 1 frame of latency at 60 frames a second than no frames of latency at 30 frames a second, because you just get a bonus extra frame every time, right? For the same effective amount of latency. So hopefully that makes some sense to you. It's just something to be aware of. It's not super relevant to Handmade Hero. You don't have to like understand it that well or anything, but that's just what's going on there. So what I wanted to point out here, because I just wanted to point out how useful profiling is, and why I wanted to spend some time showing you how to build a debug system, and why I want to have one to begin with. All we have done, right? The only thing we did so far is just show the top level debug stuff. I haven't even done the thing yet where I click and can go in here, right? I haven't even done that. So that literally all we're doing is just showing the very top level. Already, we're seeing this thing right here, which is that input processing is taking us, what is that, 2 million cycles? Right? And so think in your head, 2 million cycles. Well, you know what, we've talked about cycles before, right? We've talked about the fact that a cache miss maybe costs 100, 200 cycles, and that's really bad, right? That's like super long. It's longer than any instruction we might have. We always talk about that, missing the cache. You know, we mention that, and we're like, we really don't want to miss the cache or whatever. People say that. That's what they're talking about. But what they're talking about with miss the cache isn't a million cycles. It's 100 cycles or something, right? So we're looking at that number, and we're like, what are we doing that's going to cause that much time to be taken doing input processing? Right? We're collating 2,000 debugs of events here, right? We're processing 2,000 things. We're updating a ton of entities. We're updating hundreds of entities here. All this stuff. It's debug code, right? It's all, we haven't optimized any of it. It's all whatever. None of this is optimal. And yet, we're seeing a suitably sized chunk when compared to these things. We're seeing a suitably sized chunk of 2 million cycles for input processing. Where is that going? And that should be called, right? You should immediately be like, what's going on? I don't understand how that could be possible. I think I know what it is, because you program long enough and you tend to have a hunch about these sort of things. And I think we even mentioned it on stream way back when, but you probably have forgotten by now because it was mentioned in passing. Some of you may know, if you're an experienced programmer out there on Windows, you probably know exactly what I think it is as well. Doesn't mean we're right, it's just what we think it is. So let's just start by, I'm going to sort of approach this as if I don't immediately know exactly what to comment out, and just kind of show you how we might go about finding that. Now that we've got some tools. Well, here's our input processing, right? So even if I just don't want to think about this very hard, well, what I can do is I can just start narrowing the scope of my timing blocks. I know that anything that took that time has to come between that begin and this end down here, right? So I can pretty much just tell you right off the bat that if I was to, subdivide this, I could immediately eliminate certain pieces of the code as being potential culprits, right? And so even if I didn't think I already knew exactly what it was, I'd take this same approach and go, let's divide and conquer. Let's just add some more profiling blocks in here, and that way we can see who it is that might be taking this time. So I'm just going to go ahead and sort of make these blocks here. I'm going to go ahead and say time block, and I'm going to call these things some stuff, whatever they are. So this is going to be, what is this? This is clearing. This is like controller clearing. That's our code, right? Where it's only us there. This is Win32 message processing, right? Let's get some up in here. What have we got? Let's break this up in some. So here's keyboard messages here. This is the mouse processing, I guess, right? So this is time block mouse processing, or mouse position. In here we've got some keyboard messages. And then down at the bottom, we've got Xbox controllers. Yeah? And that's it. So that's what we're doing. Oops. New keyboard controller. These guys obviously have to be kind of lofted up a little bit. I could do a begin block, end block around them, but I think I'm not going to bother. In fact, you know what I'll do? I don't think this is a problem, so I'm just going to assume it's not. We'll see it because if it's part of that outer bit there, right? All right. So now what I want to do, and I'm kind of using this to motivate the next thing, right? Now when I run this, those blocks will be timed, right? But of course, I won't actually be able to see them. And the reason is because we're only showing the top level, right? So you can kind of see that here's that block of input processing. But I can't actually, I can't actually look at what's inside it. And so what I'd like to do is go implement the ability to narrow in on a region and figure out what's going on inside that region, right? And so hopefully you can now see why I want that, because once I know that a particular block is expensive, I want to be able to put blocks inside it and see what the different parts take. Now we could do this by just not having this block to begin with, right? I could go ahead and do that. And in fact, I suppose to make it so that we can kind of finish the train of thought, maybe I'll do it that way so we can see it. If I did this, then these would all be at the top level, but you can see why I want them to be nested, right? So it's easier for us, so we don't have to constantly put everything at the top level. But let's take a look now at what's actually taking the time. And hey, what a surprise, my suspicion is correct. The Xbox controllers are taking 2 million cycles to pull. And you may ask yourself, why does it take 2 million cycles to pull an Xbox controller? I have no idea. Do not know how they managed to write code that takes 2 million cycles to figure out whether an Xbox controller is there, considering the fact that it already knows whether the Xbox controller is there or not, because that's how you would have written the HID driver if you had any idea what was going on at all. So I have no idea what they're doing in there. But what you can determine from that profile, just like shooting fish in a barrel, right, is that polling the Xbox controllers is taking all of our time. So we are spending 2 million cycles a frame to not get Xbox controller input, right? There isn't even an Xbox controller plugged in. And I will spare you, I will spoiler warning at this point and just tell you that this is a well-known bug with Xbox controllers. I have no idea why they have never fixed it. But the problem with the Xbox controllers is that when you call X input get state, if the Xbox controller is plugged in, it will operate efficiently. So if you call Xbox controller get state with a controller index of say 0, and there is a controller index in slot 0, then you will complete immediately and it will not show up on your profile. If you call X input get state with slot 0 and there isn't a controller occupying that slot, it will take I think whatever 2 million cycles divided by 4 is. It'll take, 500,000 cycles just to tell you that there is no Xbox controller there. Right? Really heinous bug. Obviously, I reported this bug to them in 2008, I believe. And, well, you can see how fast they jumped on that one. Going on a decade. Anyway, that's the state. That's the reality of it. So we will have to work around that bug, and there's various ways that we can choose to work around that bug. One thing that we can do that's a simple fix that isn't perfect is to only pull one Xbox controller per frame if it's unplugged. So all of the controllers that are plugged in, we pull every frame, because presumably they're being used for the game and we want the input, and we know that they don't stall when they're plugged in. But every time there's one that's not plugged in, we can just not ask that for that state. We can, instead of asking, when there's 3 controllers that aren't plugged in, asking for all 3 state every frame, we only ask every 3rd frame. Right? So we ask like the first one on frame 1, second one on frame 2, third one on frame 3, thereby reducing the stall count from potentially 2 million cycles down to 500,000 cycles, right? Now again, it's not perfect because we're still losing 500,000 cycles, and we don't really want to lose 5,000 cycles. 500,000 cycles. Now, if we have other things that can be multiplexed, we could do it even less frequently, meaning we could ask only every 10 frames or 20 frames, right? But that doesn't really help us unless we have something else that only needs to happen every so often, that is going to happen, that we can also multiplex, right? Because otherwise all we've done is ensure that we're going to have one really bad frame where we lose 500,000 cycles every so many frames. And moving a potential hiccup out to only be every so many frames is not a great thing, right? We don't want that. So if we were going to try and solve the problem all the way, what we need to do is try to use a different method for figuring out whether or not the Xbox controllers are plugged in or not. And one way we could do that, for example, was try to monitor some sort of device change notifications that we might get to tell us if an Xbox controller gets plugged in or not, right? So what I'm going to do here is I'm just going to set us up for doing that at some point in the near future. I'm just going to go ahead and say, well, okay, we know that we've got this X-user max count nonsense happening here, right? So all I'm going to do is I'm going to say, let's introduce a piece of permanent storage back up here outside the main loop before we start everything. And what I'm going to do is say, okay, since we don't know, we'll just say Xbox controller present. And I'm going to say that we've got this array of assuming that none of the Xbox controllers are present for now, except for the first one, right? And so in the future, we'll try to actually keep that up to date. But what we'll do now is say, oh, okay, what we'll do is we'll only do X at input get state if that Xbox controller present array is true. So everybody else who's not set to true won't, go through this path, and they'll be marked as not connected, right? So down here, when it says controller's not available, we'll say Xbox controller present is whatever the one is, whatever controller index we're on, we'll set it to false, right? And so what we could even do, in fact, you know what we'll do here? What we could do is set them all to true at the beginning. I don't know why I set I don't know what I was doing there. What I could do here is actually do controller index equals 0, controller index is less than X user max count, and controller index plus plus. Inside here, I could just set these all to true. And then so basically what this turns our game into is this turns our game into a game where you have to have the controller plugged in at startup in order for it to work. You can't plug it in after the fact, which is not what we want. So this is not a solution, right? This is a definite to-do, which is like monitor Xbox controllers for being plugged in after the fact. So we want to go ahead and add something that will undo this, that will basically like say, oh, when I get some other kind of change notification, we'll repoll and see. But for the moment, what we'll do is we'll assume they're all present, and then as soon as we ask and find out that they're not, we'll stop polling them ever again, right? So like I said, that'll be fine for if they're plugged in the beginning. It won't handle when they're plugged in, which is not what we want, so we still want something else there. But let's go ahead and see how that affects our profile. Look at that. Look at how much nicer that is now, right? So now there's none of that nonsense going on, right? Because we're never going to pull that joystick if it's not there. And so that's great, which is what we wanted. So like I said, we have a little bit more work to do there, and that to-do is very important, so don't forget about it. That's why we put these to-dos in here. And so if the platform layer, when we go through to do our sort of final shipping pass on it, we're going to want to go study up and figure out how to get some more notifications that we can use to reset that array and requery. But for now, this will avoid us having a giant 2 million cycle time sink where Microsoft is sitting around figuring out that there aren't any Xbox controllers over and over and over and over again at great expense to us. So now that that's taken care of, let's get back to the input processing sub loop stuff that we were talking about before. So yeah. Let's see, end block. So now what I want to do is go back to focus on what I was trying to talk about with the profiler before. And so here's here's our profile. You know what? Actually, it's kind of interesting too. I'm kind of curious. Can we do? Can we do the software renderer? Do we actually get anything? Not sure why that's weird. That seems weird, doesn't it? Not sure why that's all pink. We'll have to go look at that. Because I feel like when we turn on the other renderer, we should still see something reasonable in here. And you can see that when we did it, the lane count increased. So it did, the profiler properly recorded that there were other threads doing things, but it doesn't seem to have worked properly. I don't know why this is not rendering correctly. I don't know if that has something to do with the sorting or something like that. That's real weird. Real. Yeah. That reminds me. One thing that I wanted to check, you know how we had that sort of bug where this is in the software renderer, when we blit it through OpenGL, it looks weird? I was wondering about that. And I was thinking, I wonder if we ever set sRGB on the source texture. I can't remember if we did or not. And I just wanted to look. So when we do, I think that's in OpenGL, potentially. But I can't remember. So let's take a look. Like that white, you know, I was getting that white look to it. And what I couldn't remember is when we were to do OpenGL display bitmap, when we do, okay, so there it is. So when we do GL text image 2D, what I was thinking is our frame buffer is now sRGB, I believe, but the texture that we're submitting, we're telling it that it's linear RGB. And so I was wondering if our problem was actually this, that we weren't submitting an sRGB 8 texture, if that makes sense. And I don't know. I wasn't sure if maybe that was the problem, because I was thinking maybe it was doing non-sRGB reads. And hey, look, that's what the problem was. Yeah. Cool. The other thing that I wanted to fix there, so that's perfect. So now we can switch between the software renderer and the hardware renderer. It's kind of weird, isn't it kind of interesting that our fonts look different? I'm guessing that's because we probably weren't accurate with pixel centers, I'm guessing. That's the only thing I can think of. But it's kind of cool that we can switch between software rendering and hardware rendering and get basically the exact same result. That's kind of cool, right? The other thing that I was going to say is, I don't know why that kind of got a wild hair about that. Just I saw it and I remembered I was thinking about it. So hopefully you guys see what I was doing there, right? For gamma correction, when we render with gamma correction such that we load images in, we gamma correct the values, we do all our blending operations, then we ungamma correct the values and store them back to the frame buffer. What that means, I shouldn't say I gamma correct the values. That's wrong. We map from a gamma curve space to a linear space. We do all our blending operations, and then we map from the linear space back to the gamma corrected, to the gamma encoded space, the curved space, right? And what was happening when we did our OpenGL display bitmap, or our thing that uses OpenGL to display to the screen instead of using GDI to do so, is when I set what format the texture was, when I take the results of the software renderer, which are gamma encoded, and I sent them to OpenGL, I didn't tell OpenGL they were gamma encoded. So when it went to do the rendering of the image, it was reading it as a texture and writing it to the frame buffer. The frame buffer is marked as sRGB. The texture's not. So it's reading in linear, what it thinks are linear values, even though they're gamma curve values. It's applying the gamma curve again when it copies them to the frame buffer, right? But it never applied the inverse gamma curve when it read them because it thought they were linear to begin with. So we were doing only half of a mapping, which basically re-squares our gamma, which is why everything was so bright, right? It curves a curve, right? It like takes things that were already gamma corrected and tries to gamma correct them again. So I believe that was the only bug with that. There's another bug in here though, which is that when we do GLBind texture and we set it to texture 1, now when we switch between those two, remember we've allocated a bunch of textures for use in the games when it's in hardware renderer, so we can no longer just assume that we can use texture 1. So what we want to do is we want to like reserve one texture at startup for the case where we would like to do OpenGL bitmap display, right? We essentially just want some way of setting up a global texture handle for use for this blit through. And so in order to do that, and you can see, I don't know if you guys saw it, there's a way, you can actually see a bug happen with it. So, oh, not in the profile, sorry, it's in here. So watch the background layer when I do this. Do you see what happens? I don't know if you could see that. I'll do it one more time, in case you couldn't. So here's the hardware renderer, right? Looks correct. Switch to software rendering. Obviously that looks correct. That's always going to look correct because that's not using any textures. It's just blit using one to blit to the screen. And then back, and you notice there's this weird thing in the background there. That's the image, and you can even see the text. I don't know if you could see it. You could see like texture. That's the image that we put into that texture that the software renderer made, overwriting the texture that we had sent down the graphics card to use for hardware rendering for that backplane, right? And so we need to make sure that we use a separate texture for that backplane rendering so that if we want to switch between hardware and software rendering, we are not romping an existing texture. So in order to do that, all I need to allocate a texture from the graphics card at runtime handle and say this is the one that's going to use for that, right? And so I'm going to say here that we've got one of those. So I'm going to say that we essentially have some handle here that we know we're going to reserve. And I'm going to say that we pass it in when we do OpenGL display bitmap. I'm going to pass in here like whatever that blit texture is. And so when we bind that texture in, I'm just going to have that get bound in here like so that we will never try to submit over someone's existing texture. And that way, that's just a little bit saner, I think. So in Win32 init OpenGL, in here, once I'm done with everything and we've got OpenGL initialized, I'm going to go ahead and say, okay, let's get that, let's do a gen textures call to just give us one of those. And then we'll pass that in when we do the display call so that we know that that'll always work. OpenGL display bitmap, blit texture. Okay. So now we should go through a reserved handle that will not get parceled out to somebody else. So there's the software renderer, and there's back to the hardware renderer there. And you can see that now we don't have that bug anymore. So that's just a nice, just getting rid of a bug that we would have had otherwise. So yeah, you can see that we're a little sloppy about pixel centers in the software renderer, which maybe we should go fix someday. Probably not till the game's done, because like I said, we don't need the software renderer. The software renderer is just was about teaching how those things work. But someday it'd be nice to go back and like really be rigorous about the pixel centers and make sure that everything is exactly right. Because we're really good with our interpolator, right? You can see how good we look. We look just as good as the graphics card because we did like correct bilinear filtering and correct gamma correction and all that stuff. So that's pretty cool. But our pixel centers, we never talked about that, and we never even did any. We never actually did that right. And it's not hard to get right necessarily. It doesn't it doesn't cost too many extra operations or anything to get right. It's just you have to think through the math and do it properly. So there you go. All right. How much time we got? We got no time. All right. So we've got our path clear ahead of us. Everything's working great right now. Next week, we're going to make that profile view be 10 times cooler. We'll make it so that you can navigate down the hierarchy. We'll make it so it shows the top used things. Because now we're I think we're on a roll. We've got what we need, and that's what we'll do for next week. I'm going to go ahead and take some Q&A now because I would like to take some Q&A now, and yeah, that's all good. Oh my god, Insobot. Insobot is amazing. Alright, so anyway, let's take some cues here. Can't remember what OpenGL considers the center of the pixel. So the way OpenGL works with pixel centers is that like they picked it so that if you specified the bottommost pixel coordinates exact like 0, 0, and the topmost width and height, so like one past it, with 0, 0 and 1, 1 texture coordinates, you'd get a 1-to-1 blit. I believe that's how they ended up specifying it out, which was like not the way that D3D did it originally, but they've fixed now. It was a very smart, the way OpenGL did it was a very smart way. I think it was right. I mean, I'm not really a super GPU guy, so you know, maybe there's reasons why you wouldn't want to do it that way, but it seemed like a very sane definition of it. And so what they did was they basically made it so that bilinear filtering and texture and pixel coverage lined up exactly. And that, I don't know, that just was kind of cool. Anyway, doesn't matter. Point being, is romp a synonym for clobber? Yes. Erdomina. Will the opening cutscene be narrated? Yes. In fact, I had it voice acted, but I didn't like the voice acting, so I'm going to probably get someone else to do it at some point. Erdomina, could you elucidate further on the waiting for VSync in the profiler? I'm not sure what you mean by elucidate further, but what I am trying to say about that staggering is just that when you are waiting for VSync, what that actually means is you're waiting for the GPU to tell you to proceed. That may have nothing to do with when the vertical blank occurs. It just means that you are far enough ahead of the GPU that it doesn't want you to submit any more stuff right now, right? Meaning swap buffers, what's going to happen is you're going to call swap buffers, and the graphics card might return immediately. It might just be like, okay, even though it hasn't displayed a frame yet. Then you'll get to the next time you call swap buffers and call it again, and that time it might be like, okay, wait a second. We haven't finished displaying the other frame yet. We're still waiting for VSync, so I'm just going to hold you there for a little bit, right? Because the graphics card won't let you just submit an infinite number of frames. That's not going to happen. It's going to stop once it's a certain amount behind. So then at that point, it probably is true that you will be roughly around the vsync, because it's like, okay, I cleared that frame out, and now we're moving on to the next one, like whatever, that sort of thing. But who knows? That may not be true, right? It may be that it's only once it syncs something down to be pending for vsync, it can start on the next one, and really what you're getting is waiting for that transition to occur, or who knows. So you may be staggered from the vsync quite a bit. And so I don't have anything special to add there. It's not a problem that I've studied extensively. I can't tell you what AMD's driver does or NVIDIA's driver does specifically or anything like that. I just wanted you to be aware that calling swap buffers is not the same as saying wait for the vertical retrace and display this frame. What it's saying is, here's the OpenGL commands that constitute this frame. I trust you will wait until the appropriate vblank to display it, and I also trust that you will put my thread to sleep here if I'm too far ahead of you. That's really what it's actually saying. But none of it has anything to do with return immediately after the vblank. That's not necessarily guaranteed and may oftentimes not be what happens. Cuber Caleb, I actually prefer the fonts that the software renderer produces. Is there anything we can do to make them look that way in GL? Well, to be honest, since I haven't actually looked at what's going on, I don't really even know why they're looking one way or the other way. Part of it may also be that the gamma curve in our software render is approximate, whereas the one in the hardware it's not. And around the alpha is going to have effects there. So it may be that if we re-encode the fonts with a proper sRGB curve, which at some point I actually will do in the asset packer, it may be that they look more correct there. But I don't know. Like I said, we kind of have to look. We have to look into it. Leyland7, recommended entry-level programming language for aspiring game devs. I would say that I've said this multiple times before on the stream. In fact, this is sort of Sean Barrett said something on when he was talking to Abner on Handmade, the Handmade dev interview thing. That I kind of wanted to follow up on, because I hope he wasn't talking about me when he was talking about it, because I've always said exactly the opposite of this. But he was saying that people were worried, or that people had been saying that the fact that programmers of today have JavaScript and these sorts of things, and they start on them, that they'll be lousy programmers. And that's totally not true. And he said exactly what I think is the right thing, which is that nobody started programming in C, or very few people did. Nobody starts by programming assembly language. That's very unusual. Maybe in the old days, certainly before I was born, they would have been, right? But all the rest of us, we all started in easy language too. We started in BASIC, or some kind of Logo would have been another language that we started. Everyone starts in an easier language usually. Or at least most of the time. And so you should feel free to start programming in whatever language you feel is the one you enjoy programming in and will do. Because the important thing about learning to program is doing it a lot. And so you want to start in a programming language that you get into quickly and enjoy programming in. And then when you're ready, you want to transition out of that language into a harder core language if you want to be an engine dev, right? Now, the thing that I don't know if Sean was reacting to this or not, but the part that I do think is true, and that I've said multiple times, that maybe, I don't know if maybe he thinks about this differently. The thing I do think is a problem nowadays is that nowadays you don't really have to transition to a harder core programming language, meaning you could just keep programming in JavaScript and make kind of janky, slow programs, but that you can still ship, because they won't be any worse than what Google ships or something, right? Because they ship janky, slow mail program on JavaScript or whatever, right? So you can go make a living now, and you can go make a competitive app in a number of domains without ever actually learning to program any better than in something like JavaScript. You know what I mean? And that, I think, is bad, because it means it takes away some of the incentive for people to go learn more harder core programming. And unfortunately, machines and programming has not been abstracted to the point yet where you can actually do that and not produce crappy programs, right? And so that is a part that I'm very worried about, not the entry-level part. The entry-level part, you should use whatever you want. Any language you want that you will start programming in is a good language to start with. But what you want to do eventually is, if you're going to be serious about programming, you want to move past that into a language that has low-level control, like C does, where you're thinking about actual memory that has real pointers and that sort of thing. You want to get there. And I do worry that now there's less push for people to get there, and people may stay with languages that don't have that, like Java or anything, those sorts of languages, which I don't think that's good. I don't think we're at the point in computing history where you can be that sloppy. And someday we might get there. Someday we might get to the point where our higher level languages are so good that you'd never have to think about these sorts of things again, because we boiled it all down and it's perfect or something. Or we invent some crazy new super fast computers that are thousands and thousands of times faster than what we have today. And so maybe it doesn't matter, but I don't know. So that's just to clear that up. Hopefully that's a pretty complete answer to that question. Long Boolean, is there anything that can be done to help make it easier to hover click on the debug visualization? Are you talking about the profiler? If so, then yes. What I want to do with that, and we had this before, I just don't remember, to be honest with you, I don't really remember how it worked. But we just have to have a pause. So that's all I was gonna do. But I don't remember, it's this debug state pause thing. But I just don't know if, I think maybe we just don't have any way to pause right now. So all we need is something that sets debug pause to true, and then it will stop collating new timing information, and it won't be, right, we can just, so when we're like, what's going on, we can just hit pause. We'll be able to scroll through the different frames, find the one we care about, and hover trivially. So I think we've got that covered. I don't think we're going to have too much trouble with that. And like I said, we kind of already did that. We just have to re-enable it. Let's see. Insobot is knocking it out of the park, by the way, today. Ginger Bill, are all the textures transferred every frame? No. The only textures that are transferred are ones that are freshly loaded off disk. If that makes sense. So, in fact, I can show you the. I'm assuming you're asking. I'm assuming you're not asking if OpenGL conceptually transfers them all every frame. Obviously, that's not true. But if you're asking if we do them every frame, you can see our OpenGL render loop here, which is very, very simple. And what happens is it just does a bind texture and binds the texture handle for the bitmap that is in memory. And what we do is in the asset system, when we load a texture, you can see here that anytime we're done loading a texture off disk, we immediately ask the platform layer to download it. So that's all happening on a background thread, and once it's down there, it's down there. So that's actually why now, like if we run this, so, you know, like the cutscene, for example, there's a ton of texture data. There's like, you know, each one of these scenes, some of them have, you know, 5, 6, 7 1080p bitmaps that would have to get transferred. There was a stutter there when we first implemented it, and we did download all the textures on the first frame of the cutscene. Now we do that in the background, and so we've got relatively smooth, I believe at this point, switches. I don't see any hitches anymore. So right now, actually, like as we're moving through this cutscene, it's looking ahead and going, oh, we need these other textures. They're getting loaded off the disk and downloaded while we're watching this part of the cutscene, right? So it's all sort of streamed in as it goes, which is cool, which is pretty cool. right? In the debug UI, will we be able to click on a frame and have it blit that frame? Definitely not, because in order to do that, we would have to read back the frame from the frame buffer, every frame, and save it, which we're definitely not going to do. That's basically like writing our own OBS recorder, right? Which, while an interesting exercise, is really not appropriate for Handmade Hero, because, I mean, do we really need it? Could you explain in what consists the dynamic resolution? Texture rescale, viewport rescale. At the moment, we don't really handle dynamic resolution much. We just are always at the moment rendering at 1080p and blitting to the screen. So that's, that's just something that we will look at a little bit more when we're closer to shipping. Dude in Basement 1, are we going to have it auto pause on long frames? No, I don't think so. We'll probably have some things so that it's easier for us to see that there was a long frame, but I don't think we'll auto pause. Maybe auto jump to a long frame. Hardware 2 row. What about checking for memory leaks? Yeah, we can. I probably will do some of that. I don't know how soon we would do it because, I'll be honest, I don't think we've got a lot of memory leak potential in this game. So while we do want to do some for final checking, it ain't really that big a deal, right? So I don't know that memory leaks is going to be a huge problem for us. In other contexts, maybe it would be. In this context, I don't think it's really going to be huge. So we probably will do a little bit of that, but at the moment, I don't think it's going to be super relevant. It's not high on my list, put it that way. At which point should you make the transition from a more basic language like JavaScript over to a language like C? I would say once you have gotten to the point, I would say once you've gotten to the point where you understand how to program in JavaScript, and you're not confused by it. So you understand if statements and while loops and how to make a structure, like a thing with some structured data in it. Once you can I can write a program in JavaScript, I understand how it works. I can, step through it in Chrome's thing or whatever, and I see what it's doing. I'm not confused about it. Once you're at that point, then I would say you can probably move to C. But you want to kind of because, the C has, once you move into the realm of controlling everything yourself, you just have a lot more things you have to keep in your head. And you have to understand how your memory is laid out and how you're using it and how how all of that stuff comes together. And so, the idea behind starting with a simpler language like JavaScript or, something, whatever else, basic, doesn't matter. Something, whatever that simpler language is. The idea with starting with those simpler languages is to let you practice on a subset of what programming is, right? It's like if you've never programmed before, you don't know how an if statement works. You don't know what an else clause is or why you would care. You don't know what a function is. You don't know what a return value is, right? And learning what all those things are and how to use them, more importantly, so that they become sort of more natural to you to think through, here is the problem I want to solve. How do I use all those constructs to solve that problem? It helps to start in a language where you're not thinking about memory, and you're not thinking about how do I interface with Windows, or you're not thinking about like all the things that we do think about in Handmade Hero. Removing those from the problem allows you, it's like putting training wheels on a bicycle, right? It's letting you get part of the thing done and used to it so that your brain is ready with that, so that when you take the training wheels off, instead of it being like having to learn everything at once, you can just learn now that new part, right? Which is like the direct memory control and sort of the more nuanced stuff that you have to understand when you're programming in C. And so I think for everybody it's going to be different, but that's what you're looking to do. So once you sort of get familiar with the basics of programming, then you can move on to a different language. You certainly don't have to become an expert in JavaScript, because who cares, right? So you don't need to go learn a ton about JavaScript specifically, because it doesn't matter. You just want to practice those basics, the programming fundamentals, because they're the same in every language, right? And off you go. Now, JavaScript does have one annoying thing, which is that it's dynamically typed. And so one problem with starting with JavaScript is that it won't help you catch those errors, you know? One of the nice things about C is you say something's an integer. If you then try to use it as a string, you get a compiler error, right? In JavaScript, it just sort of works, and it does the wrong thing, and your program has a bug, and you're not sure why, right? And so, there's probably a real good language for learning programming, and it's probably not JavaScript, but I don't know what it is, or if it's even has been really made yet, but, that's that. All right, I think I'm gonna go have dinner now. Let's see if there's any other Q colons. Dude in basement, sorry, have a failsafe to see when we stutter to pause the system and debug it. Unfortunately, you can't really do it that way, right? Because it's too late after you have had the stutter to debug the code, because the state has moved past there. So all you can do is look at your debug debug streams. And that, since we record forever, we don't have to pause immediately. If we see a stutter, we can just like pause. If that's what we want to do right now, we can pause and then scroll back to it, right? So we'll be able to do that as necessary, but I don't think we want it to automatically happen, because then it'll keep happening when we're in the middle of something, and that's not what we were trying to look at or whatever, right? But you can't, unfortunately, unless you do a whole bunch of other stuff I don't even remotely want to go into right now, you can't jump back and debug the stuttered frame. So. All right. All right. Let's close and save this and minimize. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can play around with it yourself and learn from it. We also have a forum site you can go to ask questions, a Patreon page you can go to if you want to subscribe to support the video series, and a tweet bot that tweets the schedule at you so you can catch the stream live. And it will be live next week again. Check the tweet bot over the weekend for what the schedule will be, because I don't know exactly what it will be next week just yet. I usually try to post it Monday morning so everyone knows what the schedule will be for the week. We also, of course, are using a new editor on stream written by Alan Webster from the Handmade Hero chat. In fact, Mr. Fourth Dimension, if you type 4coder into Google, you will have the top hit as this Patreon page. if you want to use the editor that we're now using on Handmade Hero and help fund its development, you can subscribe to his Patreon page, and I think it's the $5 level gets you the extensible version of it every month, which he updates quite frequently despite being still in school, which is pretty awesome. And every time, if you're a Handmade Hero, if you have the Handmade Hero source code as well, in the MIST directory, I keep my 4Coder customization file, 4Coder Casey, so you can use my customizations and look at how I got my editor set up if you want to. So check that out. That's about it. Have a good weekend programming, everyone, and I'll see you on the internet. Take it easy.